Good day to you children. Welcome to your science class. In today's class, we will be learning a new chapter which is named as Force and Newton's Laws of Motion. Now if you remember in your 8th standard you learned this chapter. So this time due to COVID-19 pandemic situation, as your syllabus has been reduced, only recapitulation of this chapter is to be done and some of the new concepts are to be learnt at the same time. So nothing has been skipped in this chapter. Everything which you have learned will be revised once again and new concepts will be taught. So in today's class we will be learning about Newton's first law of motion, which is also known as law of inertia. Remember children, for this chapter you have to write it in physics part and also you have to write the notes along with all the numericals which are solved in the videos, which will be solved in the upcoming videos. So without wasting any time, let's get straight into the chapter. So motivation part means I will be telling you a brief history of the origin of these laws of motion. So recognize this picture here. The person in this picture is none other than Sir Isaac Newton. And in the second picture here, this person is also one of the very famous physicists, that is Edmund Halley. And the last person here is Robert Hooke. You might recognize Robert Hooke as the discoverer of cell, the fundamental unit of living. Robert Hooke was the person who discovered cell. Robert Hooke was the person who discovered cell. So at the time when Newton was a student at Cambridge University, Robert Hooke was the president of Royal Society of England. So Isaac Newton is a British physicist, he is a British scientist, and Robert Hooke at that time was the head or the chief of Royal Society of London. So what happened? Isaac Newton proposed his discoveries of light, that light can split into 7 colors. He proposed those discoveries in front of the Royal Society. But Robert Hooke claimed that Isaac Newton had stolen his ideas and works and called them as his own. So when the question arose of how planets revolved around the sun or how objects moved and how they stopped, Edmund Halley along with another person made a bet or a challenge with Robert Hooke, who claimed that he had solved all those problems. Edmund Halley asked for proofs, but Robert Hooke never produced them. Edmund Halley heard of Isaac Newton, who was at that time in Cambridge working on his new theories and discoveries. So Edmund Halley went and sought out Isaac Newton and with his own money helped Newton publish his very first work, that is Principia. So Edmund Halley was the person who brought Newton's works to light, while Robert Hooke went on criticizing and demoralizing Isaac Newton. So there was a huge struggle between Isaac Newton and Robert Hooke, where Edmund Halley played a major role and brought the famous gravitational theories, the theories of light, and also the Newton's laws of motion, which we will be studying in the current chapter. Moving on, the very first concept which we have to focus in this chapter is force. So what is force? That is the main question. It is the force that enables us to do any work. If we want to do any work, if we want to move any object or stop any object, then force is the only thing which can help us to do any kind of work. So how do you define force? Force is defined as simple push or pull. That's what the statement says here. Force is push or pull. So for example, to open a door, either we push it or we pull it. Here, see here in the picture, a person is pushing the door and beside that another person is pulling the door. Here we are pushing the door and we are pulling the door, which means we are applying force on the door. Similarly, a drawer is pulled to open and pushed to close. So now moving ahead to type of forces. There are two types of forces, which are balanced forces and non-balanced forces. So since we know that force is push or pull, now the types of forces are balanced forces and non-balanced forces. These non-balanced forces are also called as unbalanced forces. So balanced forces, the first type of forces are balanced forces. Here you can see in the picture that two people are pushing a block, are trying to push a block from opposite directions. So here you can see the arrow marks which represent the the direction of application of force. So the person on the left is pushing the box to the right and the person on the right is pushing the box to the left, but both of them are applying same amount of force. If you see the arrows, their size is same. So both the people are applying same amount of force in opposite direction. What will happen then? Will the box move or will it stay there? The box will definitely not move. It will stay in the same place because the forces are equal and acting in opposite directions on the object. These kinds of forces are known as balanced forces. So the definition of balanced forces is when two equal forces act in opposite directions on a particular object, they produce no effect. Whenever an object experiences a force, the effects will be that either it will start to move or it will come to rest or it will change its direction. These are the three major effects of force. So when balanced forces act on a body, there will be no change in its state of motion or its state of direction. So balanced forces are those forces which are equal and act in opposite direction. They cancel each other. The force from the left side will cancel the force from the right side. That's what balanced forces are all about. For example, if you keep a book on top of a table, then you can see that the book is being pulled by the force of gravity, but the table also pushes the book in upward direction, in the direction opposite to the gravity. That is why the book kept on the table does not fall down, because balanced forces are acting on that book. So coming to the second type of force, that is non-balanced force. Here in the picture you can see that there is a tug of war happening between some students. Here two girls together on the right are pulling the rope, and on the left side there is only one boy who is being dragged towards the girls. So what is happening in this tug of war is that the force on the right, that is the force applied by the girls, is very much larger than compared to the force applied by this boy. So what happens? The rope starts to move towards the direction where force is more, where the girls are. The girls are pulling the rope towards themselves, also dragging the boy along with them. So unbalanced forces are the forces which are not equal and act in the same direction. They produce a change in the state of motion or direction of the object. For example, the engine of a train pulls the whole train with itself because of this kind of non-balanced or unbalanced forces. Similarly, in the game of cricket, when the ball hits the batsman, when he hits the ball, it starts to move away from the batsman because of the non-balanced forces acting on top of it. Coming to laws of motion, first, I hope that you recognize the person in this picture. He is none other than the father of modern physics, who is Galileo Galilei. He was the first person after Aristotle to actually experimentally study what was happening to the objects which were in motion. So what Galileo found was, from his experiments, he found that Galileo first of all said that objects move with a constant speed when no forces act on them. So if you roll a ball on the floor, then it will keep moving with the same speed if there is no force acting on it. But in reality, we know that when a ball is rolled on the floor, not just the force of gravity but also the frictional force from the floor is acting up on top of it. That is why the ball rolling on the floor eventually comes to a stop. But if there were no forces present on that ball, then it would have continued to move in the same direction without any change in its speed. So this means if an object is moving on a frictionless path and no other force is acting upon it, the object would be moving forever. It will never ever stop. That is what Galileo Galilei first said, even before Newton. Newton comes after Galileo. So before Newton, Galileo Galilei stated that the object continues to move if without any change in its speed if no force acts upon it. So Galileo Galilei was the first person to give one of his famous laws of motion. So now let us come to our main topic of discussion, that is Newton's first law of motion. So first we see the statement of the law, that is any object remains in the state of rest. Keep in mind children, this is a very important statement. Any object remains in the state of rest or in uniform motion along a straight line until it is compelled to change the state by applying an external force. So an object remains in the state of rest. If you keep a ball on the floor, then it will stay at the same position on the floor. It will stay in rest itself. It will not change its state of rest until you kick that ball, In the picture you can see here we have kept a ball on the floor. It is at rest. Rest is when the object does not change its position with time. So here the ball has been kept at rest. An object at rest will remain at rest. That is what Newton's first law says. Until a force, see here a person is kicking the ball. He is applying a force on that ball unless acted by an unbalanced force, or you can say a force, external force. So when you kick the ball was at rest first, then you kicked it. That means you applied force to the ball, so it started to move. So the ball then started to move. This is the first part of the law. An object at rest will stay at rest until an external force acts upon it. Now the ball is moving. Now since the ball is moving, an object, it is in motion, means it is changing its position with time. So an object in motion will continue with constant speed. It will not change its speed, alright. It will not change its speed, although you can observe a slight change in its speed due to friction applied by air. So with constant speed, and it will go in the same direction. Even its direction will not change. Even the direction of ball will not change until a force. Which kind of force? An unbalanced or a non-balanced force acts upon it. Here you can see the ball is stopped by a net. The net applies the required force to stop this ball from moving. Not just that, when the ball hits the net, it will slide down and move in the opposite direction. That means it also changes its direction. So the second part of the law says that the first part was about rest. If it is in rest, apply force, it will start to move. That was the first part. Now in the second part, it says that if it is in motion, it will stay in motion and go in the same direction until another external force stops it or changes its direction. That is the complete explanation of Newton's first law of motion. An object at rest will stay at rest, and an object in motion will stay in motion in the same direction until an external force or an unbalanced force acts upon it. That is the Newton's first law of motion. So another example for this is in cricket. Best example is cricket. The bowler has the ball in his hand. It is at rest in his hand. It is not changing its position. So when he bowls the ball, what happens? He is releasing the ball. He is applying some force, and the ball starts to move towards the batsman. It continues to move in that same direction. So it was at rest in his hand. He applied some force and released the ball. So now the ball is moving towards the batsman, and it will continue to move in that same direction until the batsman hits the ball with the bat, right? He hits the ball, so he is applying some force to that ball there. When he applies the force on the ball, it not just stops, sometimes it stops when it hits the stumps, but it changes its direction. So force is something which changes the direction of an object. It changes the state of motion into rest and changes the state of rest into motion. That is the action of force. So Newton's first law, the very important significance of Newton's first law is that it defines force. It also explains the effect the force has on motion of objects which we see in day-to-day life. That is the very important significance of Newton's first law of motion. So now the question arises, why it happens like that? Why can't a ball move on its own? Why does it need force? Why can't an object stop on its own? Why does it need an external force? So when we are walking, if we want to stop, we apply force towards the ground to stop. We don't stop on our own. Our legs apply the force to the ground to stop. Similarly, if we want to move, if we think that we have to move, we will not move. We have to apply the force on the ground to start moving. We push the ground away from us to move, to walk. So why it happens like that? What is the reason? The reason is our mass. Our mass is the reason for why the objects continue to stay in rest or continue to stay in motion. So that is why Newton's first law is also called as law of inertia. So what is inertia? In Kannada, it is also known as jadatva or laziness. We can even call it as laziness. So first let us see the definition of inertia. Inertia is the inability of a body. It is the inability of a body to change its state of motion on its own. If it is in rest, it will stay state of motion. When we say state of motion, it includes both rest and motion. Both states will be included there. So if a body is at rest, it will stay at rest. If a body is in motion, it will stay moving. It will not change its state on its own unless an external force acts upon it. Why it happens? It is due to its inability to change that state on its own. Or another definition is there. It is the natural tendency of the body to resist. It is the resistance. Inertia is not just the inability, it is also the resistance provided to change of state of motion. See the definition. It is the natural tendency of the body to resist the changes happening to its state of motion or rest. So it is the natural tendency of the body to resist. That is, inertia is the resistance provided to the changes occurring in its state of rest or motion. So this means more the mass. When you want to push an elephant, if you want to go and push an elephant, it is difficult to move that elephant no matter how much force you apply, because it has a larger mass and its inertia is more. Its resistance, the resistance which it provides for that motion is very high. Whereas if you want to move a toy car, a small toy car, and if you push it, it will go away, it will start to move immediately, because the mass of the toy car is very small, so its inertia is very small. Inertia is directly related to mass, keep in mind. Then there are three types of inertia. Let us now look at those types. First one is inertia of rest. That means if an object is at rest, then it stays at rest. If something is at rest, if you are sitting on a table right now, you will be sitting on a table until and unless some force acts upon you. So that is what inertia of rest means. If an object is at rest, then it stays at rest. Here you can see, here there is a small activity which has been given in your textbook too. Here we have a glass and there is a cardboard, and on top of that we have placed a coin. We have placed a coin here. So what happens when the person simply flicks the cardboard? The coin does not move with the cardboard. Instead, it falls directly into the glass. It happens because the coin is at rest and you are applying force to the cardboard. Cardboard was also at rest, but when you applied the force to it, it started to move. But there was no force acting on the coin. So what happens? The coin, which does not experience any force, it will stay in the same position, but due to gravity, due to the pull of gravity, it will start to fall into the glass tumbler that is kept below it. This is a very important example for inertia of rest. Here you can see another example. Here you can see that a giraffe is driving a car, and see that the giraffe is wearing a seat belt. So what happens when the car which is in motion and the giraffe which is sitting in the car, giraffe's head is at rest. If you can see, giraffe's head is at rest. So when the car goes and hits the wall, you can see that due to inertia, the giraffe's head started to move. If the giraffe was not wearing the seat belt, then it would have directly fallen out of the car. You must have experienced this while traveling in a bus. If you are in a bus and the bus is at rest and it starts to move, then you feel that you are suddenly you jerk behind. That happens because of inertia of rest. Your body is resisting that change of motion. It does not want to move. That resistance is inertia. Now the second type of inertia is inertia of motion. So now we come to moving objects. If a body is in motion, it will stay in motion. It will not change its state unless an external force acts upon it. So here you can see the car is in motion and it hits the wall. So the person sitting inside who was moving along with the car is thrown out of the car because of inertia of motion. Because the car stopped, but his body was moving. Due to inertia of motion, he goes on moving. That's why he is thrown out of the car, or he flies out of the car. That is inertia of motion. Similarly, when you are traveling in a bus and the bus suddenly stops, you move forward. Because inertia of motion resists that change which occurred to the bus. So that is why you move forward. It feels like you will be falling down on your face. Similarly, when you get down from a running bus or a running train, you usually run along with it for a few steps, because if you stop suddenly, you will fall down and break your leg, because inertia of motion resists that sudden rest. So you first run along with the bus or the train for a few steps and then come to a slight stop, slow stop. That is what happens there. So see here, the beads are being rolled from an inclined plane. The 4 beads are there. After coming to the finish line, they don't stop. They continue rolling. They don't stop their motion. That happens because of inertia of motion. They don't stop on their own because there is no external force acting on top of them. That is what Newton's law tells us. So now, the last type of inertia which we will be studying is inertia of direction. We said that force affects 3 things, that is state of rest, state of motion and direction of the motion, or the direction in which the object is moving. So it says that if a body is moving in one direction, it will continue to move in that direction. It will not change its direction on its own. Here I have an image for you guys. Here you can see that the ball is being hit and it is a sixer. So what happened there? The umpire shows it's a 6. So bowler bowled the ball and Rohit Sharma hit it with his bat. You can see that the direction of the ball changed after application of force from the bat. That is why the ball will continue, the ball changed its direction after application of force. Otherwise, it would have gone straight and hit the stumps. So this is inertia of direction. So to sum it up, what we learned today, we have an unbalanced force, and we have an object which is either in motion or at rest. When an unbalanced force acts on an object which is in motion, then the inertia of motion tries to resist that change. If the force is large enough, then the motion of that object will change to rest, or either it will change its direction of motion. Similarly, when an unbalanced force acts on an object which is at rest, the inertia of rest resists that change in the state of motion. But if the force is large enough, then the state of rest will be changed to state of motion. This completes your Newton's first law of motion. So today we learnt about the definition of force, some examples on force, and types of forces which were balanced forces and non-balanced forces, their definitions. Then we learnt about Galileo's law of motion, which says that an object continues to move without a change in its speed when there is no force acting on it. And then we came to Newton's first law of motion. We understood the three scenarios associated with Newton's first law, and also we learned why it happens like that. We learned that it happens so because of a property of objects known as inertia, which resists that change in state of motion, rest, or even direction. So that's all for today. In the next class, we will be learning about Newton's second law of motion. Thank you.